Hi guys, this is Mr. Smith, and you were probably expecting a video today, but you probably didn't expect me to be out in outer space in my video. So, why am I doing this? Well, there's one reason. Tomorrow is the Autumnal Equinox. I always try and do a lesson on this because it's important. It's how our seasons are made and everything. Why we have winter and why we have spring and why we have summer and fall. So right now is the first day of fall. So I'm in Universe Sandbox, which is a great game. This is how I made a lot of my videos I did over the summer. So I wanted to explain kind of what's happening with the equinox and how it works. So this is the Earth. If you look down here, you can see the date of this, the simulation right now it actually starts in 2014. So I had to let it play for like I had to speed it up and let it play for 6 years and then slow it down. So this is the very beginning of 2020, right? This is January 12th at 2:27 p.m. So this is in the daytime. So this would have been winter. January is the middle of winter, right? So I stopped it here at the beginning of 2020 to show you why we have winter. So if you look, I'm going to zoom out and get it perfectly lined up with how the Earth orbits around the sun. And you can see this is the part of Earth that we're on, right? This is Florida. This is the United States. And up here is where New Britain, Connecticut is, where we are right now. So you can see the sun is mostly hitting down here. It's down in the southern part of the Earth. And we're in the northern part of the Earth, so the sun isn't hitting us directly in the middle of January. So that's why January is winter. So I'm gonna unpause it, and we're gonna have the world spin around a little bit, and so you can see. And then that's another important thing. Let me stop it. I think this is also interesting. When we're having winter in the southern hemisphere where Australia is, they're having summer. So it's kind of interesting. Like, all parts of the world don't have winter, summer, spring, and fall at the same times. So I'm going to let it spin a little bit so you can sort of see. Here we are way up here. The sun still hits us, but it's not direct. You see that? So that was the first thing I wanted to show you. That was at the beginning of 2020. I'm going to move time forward a little bit so we can see like where it is in the summertime, where it is in the spring, and just kind of give you an idea for why it works this way. And then I'm going to fool around with some things and see what would happen if the Earth was not tilted or was tilted more. All right, so I'm going to pause it and I'll be right back. All right, guys, I'm back. So I let the simulation play until March 21st. That's around when winter is over and spring begins. That's actually the spring equinox. There's an equal amount of sun and daylight, or sun and nighttime, sorry. So let's just look. The Earth's position has changed a little bit. Like it changes. It's changed in relation to the sun. It's actually still tilting the same way, but it's in a different part of its orbit. We'll talk about that in a minute, but hopefully it's pretty slow. So I'm going to start it. So maybe I'll speed it up a little bit. So it's not, the sun's still, like the equator's still down here somewhere. So the sun is not entirely differently and actually let's turn it. Yeah, that's better. So this is the part of the Earth that the sun is pointing at. So you can see it's a little different now. And actually, we might be... Let me see. Let's fix it so we're on the same orbital plane too. That helps. So, okay, let's stop it there. So before, Connecticut was way up here, right? So now Connecticut's a little farther south. You see that? It's not a little farther south, but it's closer to where the sun is shining. The sun is shining more directly closer to Connecticut. So this is why it starts to get warmer in the spring. You see that, guys? So let me show you this. So I'm gonna It's hard to show. It's hard to show all the angles like from the. Let me do this. We will click on. Do I have it paused? I do have it paused. So we'll click on the sun. We'll make that our reference point, and then we'll look from top down. Okay, so the Earth is right here, right? So that's where the Earth is in March. So the sun is pointing at a different place. So I'm going to let the simulation go and maybe speed it up a little bit. So we can see summer starts. When does summer start? The beginning of summer, I believe, is June 21st. So let's speed it up and go to June. Okay, don't go too fast. It's hard to do this just right. So you see how the Earth is moving around the sun? Okay, we're about where I want to be. So we're going to pause it there. So now the Earth has gone from over here to over here. So let's see if the part of the Earth the sun is shining on is different now. It's going to look a little different because now it's summertime in Connecticut. So let's zoom in on the Earth. We have to turn our angle a little bit. Let's zoom out. Yeah, we have to change our angle a lot, but that's okay. So now we're going to zoom in and look at the part of the Earth the sun is shining on. Okay, see now it's still going too fast. Don't go that fast. All right, so now when I start it, if you see, the sun is now shining on a different part because we're in a different part of our orbit and the Earth is tilted. So that's where Connecticut is right there. So now instead of being way up here where it is in January, it's down here. So this was summer. This was when we were going to summer school. This was when we were having remote learning and everything. Actually, 6:15. Yeah, we were still in school, but only for a few more days. So that's kind of how the seasons change because the Earth is tilted. Kind of do this lesson in school usually, and we kind of sit in the classroom, but we can't do it that way this year. So I thought this would be more fun, or a little easier way to do it from distance learning. I don't know. So anyways, let's look at where we are now. Tomorrow at 8:30 is the autumnal equinox. That's when autumn starts. That is see, you'll notice it's starting to get colder, right? So let's see where things are if we speed things up a little bit and go to September 21st or 22. I gotta speed it up a lot. We're gonna start moving. It starts going pretty quick and then I have to slow it down. Okay, so oh, we're gonna have to, okay. All right, stop. I gotta pause it. All right. So we're like 9:22. That's like Wednesday, but that's pretty close. All right. So you can see instead of it started over here in January, then we were over here. Now we're over here. We've orbited the sun. We've moved a little bit farther in our orbit, but the Earth is still tilted the same amount. So a different part of the Earth is now the part that's facing the sun more directly. So let's look. Let's get this lined up correctly. Oh, and now it's, of course, it's over the ocean. So now Australia's down here. That's what we kind of looked at before. When we were having winter, they were having summer, right? So we'll speed this up a little bit. Oh, that's a little too fast. So now Connecticut's back up here. So now our days are a little bit cooler because we're a little bit farther away from the sun when we were in summertime, right? So that's kind of how it works. In the summertime, the Earth, the sun shines on Earth more directly near where Connecticut is. In the wintertime, the sun shines on Earth less directly where Connecticut is. So it's winter, it's colder, the sun's farther away. So that's kind of how that works. We can speed it up and go to December 21st, 22nd when winter actually starts and see where it is then. Hopefully I didn't make it go too fast. No, that's not too bad. So So let's speed this up a little bit faster. It's like I have a time machine. Alright, so it's about to be Halloween. Hopefully it won't get canceled this year. No, it's Halloween, guys. Now it's November. Get ready for Thanksgiving. Oh, it's gonna be Thanksgiving. Happy Turkey. Happy Turkey Day. We're gonna turn our view a little bit because we need to be looking at the part the sun is shining on for this to make any sense, right? So then we're gonna go to about 21. There we go. So now this is when winter starts for us, right? So if we let it play, let's make sure our orbital plane is correct. I know that probably doesn't make a lot of sense to you, but it's important for this demonstration that we're lined up the right way. Okay, see, the sun is shining almost directly where, like, Australia is. And if we let the Earth kind of spin a little bit, and then slow it down, you can see Connecticut is now way up on top. Not very close to where the sun is directly shining, right? So that's why tomorrow is the equinox, because we're tilted towards the sun, and we're in that September tilt that I showed you, where our day and night is about equal, and it's starting to get colder. We're starting to move away. So cool thing about this simulation is it's pretty realistic as far as how the Earth is. So we can look at, like, this is the polar ice caps. This is Antarctica, right? So we can kind of fool around and change something. It's called sandbox for a reason, right? So let's change the tilt of the Earth and see if our seasons would be different. So let's slow it down, and then we're gonna go to this motion tab, orbital plane. So we orbit at a 23.4 degree angle, right? That's how much our Earth is tilted. So I can change, in this simulation, I could change that. I could make the Earth upside down if I wanted to. Look at that. We don't want to make things upside down. But we could change it to 0. So now it's not tilted at all. Right? So I can play the simulation and we can see what happens. So let's speed things up. Alright, now let's pause it and look at the Earth and see if things are different. So if you see here, all we did was take the tilt off of the Earth, right? The Earth's not tilted anymore. So it's always the same angle at the sun. Look at this. The polar ice caps reach all the way down almost to Mexico. Like, there's just snow all the time. Over here, this is like Japan is over here. This is Russia. This is mostly snow. It's crazy, right, guys? Antarctica doesn't look very different. Okay, so let's try something else. Let's tilt the Earth the other way and have more of a tilt than we normally do. So, and see, now it's tilted a little bit, I think, because the simulation does things with gravity and stuff, and it'll automatically, like, tilt. But anyways, alright, so let's change the tilt to a lot. Like, it's tilted a lot. So now it's tilted more than it was before. Let's see how it changes. This is how important the tilt of the Earth is, guys. So now the Earth is tilted this way. Like, it's like twice, it's more than twice as much, and the North Pole is facing the sun. And then part of the Earth's facing away from the sun. So let's speed up the simulation and see what happens now. Oh, I've done pause it. Whoa, 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 okay. Well, that's crazy. Alright, so now, look at that. changing the tilt of the Earth made all of North America frozen, all of South America frozen, and then the other half is not frozen. So the tilt of the Earth makes a big difference in our seasons. It has to be exactly right the way it is for us to have our seasons the way we do. All right, so I don't know if that all makes sense to you guys, but I thought we'd have a little fun with this and talk about it. Tomorrow morning is the autumnal equinox. It's not actually today, but we don't have science tomorrow, so I thought it'd be fun to talk about today. So anyways, hope you enjoyed this video. I hope it explained something to you. Let's put the Earth back. Actually, let's... Oh, now the Earth is upside down. It's 180 degrees. Let's see what happens if I speed it up now. I know, I said I was going to go, but let's just see what happens. Okay, so it's nighttime in Africa. Well, we thawed things out a little bit, but we're still frozen. Actually, Connecticut's not frozen. Connecticut's right here. Although it's weird to look at it upside down. But most of America's frozen and into Mexico. So that's crazy. So that is how important the tilt of our Earth is and why we have seasons and why a little bit of how that works. Okay, guys? So anyways, thanks for being patient and watching this video. I know I'm a little weird sometimes with my videos, but I try and find neat ways to explain things to you guys. So anyways, have a great day, guys. Bye.